In this gas stoichiometry problem, we are going to use both stoichiometry and the ideal gas law. The problem reads, the safety airbags in automobiles are inflated by nitrogen gas generated by the rapid decomposition of sodium azide, NaN3. According to this reaction, 2NaN3 yield 2Na plus 3N2. If an airbag has a volume of 32 liters and is to be filled with nitrogen gas at a pressure of 1.4 atmospheres at a temperature of 24.0 degrees Celsius, how many grams of NaN3 must be decomposed? So because this question is asking for grams of NaN3, a substance that is not a gas, we must first start with the ideal gas law, PV equals nRT, solve for moles, and then use stoichiometry to convert moles of one substance into moles of a different substance, and then convert those moles to grams. So, because we have a balanced equation already, we can go right into our PV equals nRT equation. Pressure has been given to us, 1.4 atmospheres. Volume is given 32 liters. N is what we'll be solving for, the number of moles. R, the ideal gas constant, is 0.0821, and T is temperature, which a reminder must be in Kelvin. So because we are given 20.40 degrees Celsius, we need to add 273 to give us 297 Kelvin. We plug that into our ideal gas law equation, and then we solve for N. When you do that, you should get an answer of 1.84 moles, and that's moles of nitrogen, because a reminder that the ideal gas law can only be used to calculate moles of a gas, and in this particular equation, N2 is the gas in the equation. So we now have 1.84 moles of N2, and we're going to use stoichiometry to convert moles of N2 into moles of NaN3, and then we'll switch it to grams of NaN3 because that's what the question's asking for. So we have 1.84 moles of N2, and our first step will be to use coefficients to do a mole-to-mole ratio conversion. So for every 3 moles of N2 that we have, we would need 2 moles of NaN3. And then we can do a second step and go straight from moles of NaN3 to grams of NaN3 using the molar mass. And so in 1 mole of NaN3, there are 65 grams. And then when you do all of this math, you should get a final answer of 79.73 grams of NaN3.